The James Webb Space Telescope was supposed to confirm our understanding of the cosmos, but instead, it's shattering the very laws of physics. From impossible early galaxies and naked black holes to evidence that reality itself is breaking down, everything you thought you knew about the universe is about to change. 13 billion light-years away from our home planet, within the freezing emptiness of the cosmos, an absolute impossibility is looking right back at humanity. By gazing further into the endless cosmic dark than any previous observatory, the James Webb Space Telescope has uncovered phenomena that completely shatter our accepted rules of physics. We are now seeing impossibly old galaxies that have no right to be there, black holes predating time itself, and mysterious transmissions from wandering planets echoing through the deep void. Get ready to have your mind completely blown, because our incredible journey starts right now. And the very first stop on this journey reveals that the universe itself is hiding a massive, terrifying secret. For a long time, researchers felt completely confident about the expansion rate of our cosmos. They had a neat cosmic jigsaw puzzle where mathematical predictions matched the data collected by the Hubble Space Telescope. However, the moment the James Webb Space Telescope peered deeper into the void than ever before, that neat picture shattered into a million pieces. It turns out the cosmos is actually stretching at two totally distinct rates, entirely dependent on your method of measurement. Imagine blowing up a balloon where the upper half inflates at double the speed of the lower half. According to the established rules of physics, space must stretch evenly everywhere, making this scenario completely impossible. Yet, Webb validated the worst nightmares of astronomers. Calculating the stretch rate via the cosmic microwave background radiation yields one specific value, while observing distant pulsating stars known as Cepheid variables produces a totally conflicting figure. This isn't just a tiny mathematical glitch, either. The gap between these two numbers is so enormous that it implies our core comprehension of reality is deeply flawed. Experts refer to this dilemma as the Hubble tension, though that mild label hardly does justice to the sheer nightmare we are facing. We aren't looking at a simple equipment miscalibration or a minor observational mistake. Even after analyzing more than 1,000 Cepheid stars spread across 5 different galaxies located 130 million light-years away, the glaring mismatch persists. The consequences of this are absolutely mind-boggling. It means either our foundational models of the cosmos are totally busted, or an unseen force is literally ripping the fabric of reality apart. Perhaps dark energy, the enigmatic driver of cosmic stretching, is acting in completely unexpected ways. Certain pockets of the void might be inflating much quicker than their surroundings, potentially tearing open cosmic rifts that defy all our current knowledge of spacetime. Adam Rees, the lead scientist behind this discovery, stated the situation perfectly. Now that observational errors are off the table, we are left with the thrilling yet terrifying reality that we have completely misinterpreted how the universe operates. Honestly, calling it thrilling feels like a massive understatement when you grasp the actual stakes. If we are wrong about this basic expansion mechanic, then every single calculation regarding the age, total size, and final destiny of the cosmos is suddenly unreliable. Thanks to the unparalleled accuracy of the James Webb Space Telescope, all lingering doubts about the data have vanished. Both Hubble and Webb are observing this exact same physics-defying paradox. The cosmos is definitely growing, but it is doing so in a manner that shatters our known physical laws. Finding this single anomaly would be plenty to rewrite every astronomy textbook on the planet. However, the telescope was only just warming up. While scanning the deepest reaches of space, it started uncovering impossible objects, baffling behaviors, and bizarre events hinting that our reality is much weirder and far more hazardous than anyone ever guessed. This expansion dilemma merely kicked off a chain reaction of revelations that would make experts doubt their entire cosmic education. Yet, as mind-bending as that was, the next thing Webb uncovered would make this crisis look incredibly simple by comparison. Moving past that newly simplified crisis, Webb turned its infrared gaze toward a blank-looking patch of space near the Big Dipper. Researchers were simply hoping to spot miniature, infant galaxies navigating their initial billion years. What they actually found, however, was a group of 6 colossal, fully developed star clusters that completely defied the cosmic clock. Rivaling the Milky Way's stellar population, these behemoths emerged when the cosmos was a mere 3% of its present age. Imagine planting an acorn and watching it transform into a towering oak tree in just 3 months. On a universal scale, that is exactly what these 6 structures achieved. Normally, birthing stars is a sluggish process, requiring gravity to spend millions of years gathering dust and gas before nuclear fusion can spark. Somehow, though, these 6 anomalies accelerated their growth, transforming into immense titans while the cosmos was still in its absolute infancy. This mind-blowing find was actually a happy accident. While scanning tiny, postage stamp-sized crops of Webb's deep field photographs, astrophysicist Erica Nelson noticed a cluster of blurry red specks shining with impossible intensity. In the realm of astronomy, red hues typically indicate ancient light stretched out by cosmic expansion over its massive journey to our telescopes. However, these specific anomalies were not just incredibly old. They were also radiating a blinding brilliance, creating a paradox that simply refused to make sense. Inside each monstrous galaxy, you will find 10 billion to 100 billion individual stars. Achieving such a gargantuan scale in such a brief window meant they had to birth hundreds of fresh stars every year, consistently, for hundreds of millions of years. When you consider that our own Milky Way produces a measly 2 new stars each year, the sheer output of these ancient factories becomes staggering. They were churning out stellar bodies at a manufacturing speed that modern physics firmly declares cannot happen. Because they actively shatter our established rules for cosmic architecture, the research team casually dubbed these anomalies universe breakers. Every computer model and scientific simulation dictates that primordial matter should have gathered in a slow, deliberate fashion. Tiny formations were supposed to gradually collide and merge into bigger structures across billions of years. These 6 giants completely obliterate that established timeline, hinting that the young cosmos possessed a level of intricate organization experts never thought conceivable. This leaves us with a stark choice. Either a totally undiscovered process drives rapid galactic assembly, or our core beliefs regarding cosmic evolution are fundamentally flawed. Furthermore, this revelation introduces alarming doubts regarding how dark matter influenced the young cosmos. If these galaxies could balloon to such massive proportions so rapidly, dark matter must have been aggregating and dragging in normal matter at speeds that wildly surpass current forecasts. The unseen framework holding the universe together could be significantly more chaotic and aggressive than we ever suspected. Astronomer Joel Lee, who is actively investigating these structures, summarized the sheer scale of this dilemma perfectly. He noted that peering into the deepest past of the cosmos yielded something so astonishingly unexpected that it poses legitimate, severe challenges to modern science. Still, verifying the true galactic nature of these objects demanded further scrutiny using Webb's spectrograph instruments. As it turns out, the data pulled from those subsequent observations would uncover a reality far more unsettling than anyone could have ever predicted. That unsettling reality quickly took the form of a solitary giant roaming the cosmos. Imagine a beast weighing 50 million suns, drifting through the void completely alone and forcing us to rewrite cosmic history. Buried deep in the dawn of time, the James Webb Space Telescope spotted an anomaly shattering every established rule of black hole creation. Meet QSON, a supermassive black hole stripped of its usual galactic clothing. Unlike typical supermassive black holes acting as gravitational anchors at the heart of galaxies, surrounded by swirling disks of dust, gas, and billions of stars, this one is completely bare. Normally, these giants and their hosts share a symbiotic bond, evolving together over eons through a careful balance of star birth and gravity. But QSON throws that entire playbook out the window. This lone wanderer, packs 50 million solar masses into a space tinier than our own solar system. To visualize this mind-bending scale, picture Earth shrunk to the size of a tiny marble. Even then, QSON would remain invisible to your bare eyes, yet hold more material than hundreds of billions of regular stars combined. The most mind-boggling aspect, however, is its timing. QSON existed during the universe's infancy, a mere 600 million years post-Big Bang. Standard models dictate black holes form from the explosive deaths of giant stars, requiring the first stars to ignite, live, and detonate as supernovas. That life cycle takes far longer than 600 million years. Cambridge astrophysicist Roberto Maialino, a key researcher behind the discovery, captured the shock by calling the object completely off the scale. It contradicts every scientific framework regarding early supermassive black hole development. Scientists propose three explanations, each wilder than the last. Theory 1 argues colossal gas clouds collapse straight into black holes, skipping the star-forming stage entirely. Theory 2 suggests medium-sized black holes fed at impossible speeds, consuming matter faster than physics permits. The third concept is the most chilling. QSON could be a primordial black hole, birthed during chaotic spacetime ripples in the first seconds after the Big Bang. If true, it has hidden in the dark since day one, waiting 13 billion years for stars to finally light it up. QSON isn't alone. It belongs to hundreds of comparable anomalies Webb detected. Scattered across the early cosmos, these little red dots shine as they superheat material spiraling down their gravitational drains. Finding these exposed black holes hints the infant universe was incredibly violent, contrary to the slow, organized construction we once believed. We might be witnessing ancient catastrophes that forged giant black holes before the first star sparked. If QSON is a primordial relic, it is vastly older and stranger than any standard galaxy. Yet, it wasn't the only impossible black hole Webb found hiding in the deep universe. In fact, the telescope soon uncovered black holes predating the very first stars, illuminating the cosmos almost from the exact moment of creation. For decades, researchers believed giant black holes only appeared after the earliest massive stars died. This standard sequence requires hundreds of millions of years. Gravity must slowly gather material to spark nuclear fusion, allowing stars to shine briefly before detonating as supernovas and leaving dense remnants. However, Webb shattered this timeline by revealing giant black holes when the cosmos was a mere 400 million years old. That is simply not enough time for the standard stellar collapse model. To solve this mystery, Andrea Ferrara and his research group at the Superior Normal School in Pisa, Italy, introduced a wildly different idea. They asked a groundbreaking question: could black holes, rather than stars, be the original light bulbs of the cosmos? Specifically, they suggested primordial black holes, born during the chaotic initial seconds following the Big Bang, were already waiting in the shadows while the universe was just a baby. These theoretical ancient voids would originate through a totally unique process compared to their stellar cousins. Rather than dying stars, they would spring from intense density spikes within the primordial soup, occurring less than 5 seconds after the universe began. Imagine the infant cosmos as a furiously boiling cauldron of matter and energy, where certain pockets became so incredibly packed that they instantly crumpled into black holes, skipping the star phase entirely. Data collected by Webb strongly backs up this wild concept. Many luminous objects spotted in the deep past look like tiny dots instead of sprawling structures, pointing to concentrated power sources instead of widespread star birth. As material spirals toward a black hole, it reaches extreme temperatures and radiates intense brilliance. Viewed from far away, this glowing, superheated gas perfectly mimics starlight. If true, these ancient voids were devouring the earliest gas clouds, bulking up and illuminating the dark expanse simultaneously. These colossal entities lurked in the shadows for eons, basically just waiting for the cosmos to mature enough to serve up a steady meal. The consequences are mind-blowing. It perfectly explains how giant black holes achieved such unbelievable sizes so rapidly, giving them a massive head start long before the earliest galaxies took shape. Yet this concept brings up unsettling thoughts. If these primordial voids were everywhere back then, they could still be drifting around right now, completely hidden. A few might even roam through the Milky Way, acting as ancient ghosts from the violent dawn of time, older than any visible star. Finding these giants forces a total rewrite of cosmic history. Rather than a universe that slowly constructed complex structures from basic ingredients, we might inhabit a reality born with colossal entities already baked into its foundation. Spotting these ancient voids would also unlock vital secrets about Big Bang physics, exposing unimaginable conditions from the very first fractions of a second. However, as Webb continued studying these anomalies, it stumbled upon an even weirder mystery challenging gravity itself. This mind-bending puzzle involves a colossal cosmic train wreck where two galaxies are smashing together, generating physics that defy our current understanding. Researchers quickly dubbed this striking object the Infinity Galaxy because of its jaw-dropping visual structure. Featuring a flawless figure-8 design that mirrors the mathematical symbol for infinity, this bizarre system boasts two dense red centers encircled by luminous rings. Yet this striking visual is merely the tip of the iceberg. Millions of years ago, a spectacular head-on impact between two giant disk galaxies birthed this unique formation. While galactic impacts happen fairly often across the cosmos, the outcome of this specific event is completely one of a kind. Rather than undergoing a messy, destructive merger that obliterates their original forms, both galaxies somehow kept their distinct structures intact while simultaneously forging a brand new cosmic entity. The absolute strangest part of this entire event, however, is exactly where the supermassive black hole is hanging out. During standard galactic mergers, the central black holes typically spiral inward to either combine into one giant singularity or kick one another out of the system entirely. This system totally shatters that rulebook. Here, the supermassive black hole is parked right in the middle of the two galactic cores. It is just hovering within a massive cloud of luminous hydrogen gas that was ripped from both galaxies during the impact. Gravitationally speaking, this setup makes zero sense. Instead of being dragged toward one of the dense nuclei, the black hole is just floating dead center, acting almost like a cosmic referee watching the galactic pileup. The astronomers behind this discovery, Peter van Dochem and Gabriel Brahma, suspect they are looking at a rare phenomenon known as direct collapse black hole formation. Rather than being born from the explosive deaths of giant stars, this specific black hole likely originated from a colossal gas cloud collapsing in on itself during the galactic smash-up. Here is how the mechanism operates. The initial impact generated gigantic rivers of gas flowing between the two galactic centers. If the environment is perfectly aligned, these gas flows become incredibly thick and heavy, imploding straight into a black hole without ever igniting into stars first. You can picture it as a cosmic avalanche so intensely powerful that it instantly carves out its own gravitational prison. This exact shortcut to black hole creation might just solve one of the James Webb Space Telescope's most frustrating early universe riddles. Webb keeps spotting supermassive black holes that are simply too gigantic for their young age, ballooning to massive proportions way faster than standard physics permits. But if these objects can spawn directly from imploding gas clouds, they could achieve supermassive scales in a fraction of the usual time. Because of this, the Infinity Galaxy serves as a perfect, real-time testing ground to observe this wild formation method in action. Right now, the black hole seems to be greedily snacking on the gas streaming between the two cores, packing on weight as the crash unfolds. In fact, radio telescope data reveals massive bursts of energy radiating from the black hole's exact coordinates, proving beyond a doubt that it is actively devouring surrounding material. Yet, the most unsettling takeaway from the Infinity Galaxy isn't just the spectacular light show we are witnessing today. It is what this event implies about the brutal, chaotic forces that molded the infant universe. If direct collapse was a regular occurrence back then, it tells us the early cosmos endured an era of unimaginable violence and turbulence that we are just starting to grasp. Ultimately, That extreme cosmic brutality left behind relics that are even weirder than wandering black holes. Speaking of bizarre relics, imagine hundreds of orphaned worlds drifting through the void in pairs, broadcasting radio signals that simply shouldn't be there. The James Webb Space Telescope has spotted more than 500 free-floating planets hiding out in the Orion Nebula, completely untethered from any host star. Roughly the mass of Jupiter, these rogue globes were violently kicked out of their birth systems and now wander the freezing vacuum of interstellar space. But the real twist is that a huge number of them are cruising together in couples. They orbit one another at massive distances, ranging anywhere from 25 to 400 times the gap between the Earth and the Sun. Researchers have dubbed these DOOs Jupiter Mass Binary Objects, or JWMBO for short. Their very existence throws our standard models of planetary birth out the window. Normally, worlds build up slowly by gathering gas and dust in the swirling disks around infant stars. The precise gravitational choreography needed to forge a binary planet pair should be exceptionally uncommon, yet Webb has uncovered dozens of these cosmic couples. The plot thickened massively when researchers aimed radio telescopes at these DOOs and picked up something totally unheard of. Multiple JWMBO are blasting out radio waves with completely alien patterns. We aren't talking about the standard static you get when a magnetic field messes with charged particles. Instead, they are firing off gigahertz frequency bursts pitched thousands of times higher than your standard FM radio station. Back on Earth, you only hear frequencies this high from human technology or ultraviolet cosmic beasts like quasars and pulsars. Hearing this from wandering planets implies they are undergoing extreme physical reactions totally absent from our own solar neighborhood. This bizarre broadcasting seems directly tied to their twin nature. As two heavyweight bodies circle each other, their intense gravitational tug-of-war whips up massive electrical currents and magnetic fields. You can picture it as an extreme form of cosmic friction on a scale we have never witnessed. Basically, these JWMBO function as colossal electrical generators fueled by their endless orbital waltz. Still, the exact nature of the broadcasts is a massive head-scratcher. Every single JWMBO pair flashes a distinct radio fingerprint, meaning each binary boasts its own quirky electromagnetic personality. A few pump out a constant flow of waves, whereas others spit out random, unpredictable bursts. The consequences of this are honestly a bit chilling. If these exiled planets can crank out such intense radio noise, what other tricks are they hiding? Their magnetic fields might be exponentially more powerful than anything near Earth, potentially whipping up wild space weather that could even mess with neighboring star systems. Furthermore, the sheer volume of JWMBO paints a grim picture of how planetary systems evolve. If a single nebula holds hundreds of these twins, our Milky Way could be swarming with millions or billions of them. Every single one is a monument to a failed solar system, a gravitational disaster that banished these globes into the endless dark. Stripped of a sun's warmth, these orphaned twins survive in absolute blackness. Their only internal warmth comes from the sluggish breakdown of radioactive materials deep in their cores, combined with the tidal squeezing from their partner's gravity. Yet, as mind-bending as these roaming twins are, Webb has uncovered even crazier anomalies that shatter our foundational knowledge of planetary birth. The upcoming revelation would compel experts to completely rewrite the rulebook on how worlds take shape around infant stars. That rulebook rewrite begins in a stellar nursery called NGC 6357, where a youthful star system is breaking all the standard guidelines by building planets out of the wrong stuff. Using the James Webb Space Telescope, researchers spotted a protoplanetary disk around a star named XUE-10. Right in the exact zone where Earth-like rocky worlds usually assemble, this disk is packed with carbon dioxide, but completely lacking in water. This observation totally destroys our core beliefs regarding the birth of rocky planets. Standard models dictate that the inner zones of young stars, where terrestrial planets grow, must be overflowing with silicate minerals, ice, and water. Since water is incredibly common across the cosmos, scientists have always viewed it as a mandatory ingredient for forging potentially life-supporting globes. Yet the XUE-10 disk throws those textbook ideas out the window. When astronomers pointed Webb's near-infrared spectrograph at this system, they fully anticipated detecting the usual chemical fingerprint of water vapor blended with standard compounds. To their shock, the interplanetary construction zone was entirely taken over by carbon dioxide. H2O is so incredibly rare here that the instruments can barely pick it up, resulting in a setup that defies all existing computer simulations. Such a find turns our grasp of planetary chemistry upside down. Back home, water was absolutely vital for shaping Earth's atmosphere, geology, and the eventual spark of biology. Any world coalescing within the XUE-10 environment will evolve under radically alien chemical rules, likely birthing planet types with zero equivalents in our own cosmic neighborhood. Experts have proposed a pair of hypotheses to decode this weird chemical recipe, and both carry some pretty chilling consequences. Hypothesis number 1 argues that fierce ultraviolet light, either from the central infant star or neighboring giant stars, effectively blasted the disk. This intense radiation would shatter water molecules, blowing the hydrogen into space and forcing the leftover oxygen to bond with carbon. The alternative idea is arguably even creepier. The carbon dioxide takeover might stem from bizarre traits within the disk's actual dust particles. Rather than wearing a cozy jacket of water ice like normal dust, these specific grains could be cloaked in carbon dioxide thanks to the unique local environment. Whichever scenario is true, it proves that solar systems can assemble through completely uncharted routes. If UV light can easily vaporize and strip water from these disks, countless potentially life-friendly planets might be robbed of their vital chemical foundations. Our Milky Way might actually be teeming with arid, carbon dioxide-heavy globes born in settings totally toxic to biology as we know it. This revelation also forces us to rethink just how varied alien solar systems can be. If the planet-building process can cook up such wildly contrasting chemical soups, there could be whole families of exoplanets driven by atmospheric and geological mechanics we have never even dreamed of. Ultimately, XUE-10 serves as a perfect cosmic testing ground for exploring these bizarre alternate birth paths. As its newborn planets keep growing, they will teach us exactly how globes assemble when the foundational recipe is entirely foreign to our solar system. However, this bizarre chemical puzzle was merely the tip of the iceberg for Webb's atmospheric investigations. The observatory's subsequent focus would expose an environment so fiercely hostile and extraterrestrial that it forces us to redefine the very concept of a planetary atmosphere. Stepping into this redefined reality, we find a realm positioned so near to its host star that its exterior shines like liquid metal, yet it mysteriously clings to an envelope of gases that shatters all known planetary rules. Completing an entire orbit in a mere 18 Earth hours, 55 Cancri E sits in an ultra-tight embrace with its sun. Because it is tidally locked, one hemisphere perpetually stares into the stellar glare, heating up enough to liquefy copper, while the opposite hemisphere remains trapped in endless, freezing night. With surface heat soaring past 4,000 degrees Fahrenheit, nearly every recognized substance turns to vapor. According to standard physics, any gaseous envelope here should have been blasted away eons ago. Yet, the James Webb Space Telescope uncovered a mind-bending reality. This scorching sphere actually possesses a substantial atmosphere filled with compounds that theoretically cannot remain gaseous under such brutal conditions. Rather than being a barren, airless rock like Mercury, it is wrapped in a dense shroud heavily loaded with carbon dioxide and carbon monoxide. Scientists made this breakthrough by utilizing Webb's mid-infrared instrument to meticulously track the planet's thermal emissions. The dayside was surprisingly cooler than models predicted, revealing that a dense atmospheric layer was actively absorbing and shifting the stellar energy toward the dark side. This heat transfer drives a weather system of unimaginable fury. Picture supersonic gales screaming across the landscape at thousands of miles per hour, hauling vaporized stone and metal toward the unlit hemisphere. Once there, the extreme chill forces these vapors to condense, dropping back to the surface as a terrifying downpour of liquid rock and molten minerals. While the thermal gap between the two hemispheres ought to exceed 3,000 degrees, these massive convection currents smooth out the extremes, functioning in ways no terrestrial lab could ever simulate. The true mystery, however, lies in where these gases originate. They cannot be leftover primordial clouds, as the fierce stellar winds would have eradicated them within a few million years. Instead, experts conclude this is a secondary atmosphere continuously erupting from deep within the planet. Driven by immense tidal friction and blistering heat, the world's interior is essentially boiling, forcing subterranean carbon-rich compounds to vaporize and vent outward through relentless volcanic outgassing. It is a violent, continuous loop. Stellar rays constantly strip the gases away, while extreme geological forces instantly replace them. Vaporized crust shoots upward, gets swept across the globe by roaring winds, cools in the dark, and precipitates as liquid stone, turning the entire globe into a gigantic, physics-defying distillation machine. Finding a stable atmosphere on 55 Cancri proves that gases can endure environments far more brutal than anyone imagined. This radically shifts our perspective on habitability, suggesting that worlds previously dismissed as completely dead might actually harbor complex atmospheric chemistry. However, this blazing inferno was merely the opening act for Webb's next mind-boggling revelation, as the observatory soon locked onto an interstellar wanderer poised to rewrite our comprehension of cosmic time. That interstellar wanderer turned out to be an ancient comet hurtling through our solar neighborhood from another star system. At first glance, Comet 3I Atlas appears completely unremarkable. Measuring 7 miles across, this ice and rock mixture will sling around our sun before shooting back out into the deep void between the stars. However, a detailed inspection by the James Webb Space Telescope uncovered an impossibility. This space traveler is roughly 7 billion years old, making it 3 billion years senior to our entire solar system. It is older than the Sun, Earth, and everything we call home. By mapping its steep flight path, researchers realized it originated in the Milky Way's thick disk, a zone packed with ancient stars born during the universe's infancy. This cosmic nomad has floated through the dark expanse since before our sun was a tiny spark in a stellar nursery, predating Jupiter, Mars, Earth, and every single planet in our local neighborhood. When Webb used its near-infrared spectrograph to study the comet's coma, the dusty, gaseous halo enveloping its core, it found a shock. Instead of the standard water vapor seen in local comets, this cloud is overwhelmingly carbon dioxide. This bizarre makeup offers a rare window into the chemical conditions of its birth star system eons ago. Zooming at a blistering 130,000 miles per hour, this object could traverse the entire United States in under 2 minutes. Its flight path is remarkably straight and flat, completely unlike anything else we observe in our solar system. Rather than obeying the sun's gravitational pull, this interstellar guest follows the galaxy's broader gravitational laws, treating our entire solar system as a minor roadblock. The truly mind-bending aspect of this ancient tourist is the era it represents. Acting as a messenger from 7 billion years ago, it hails from a time when the Milky Way was far more violent and chaotic. Back then, heavy elements were scarcer, stars birthed faster, and planet-building chemical recipes were radically different. Comet 3I Atlas formed around a host star that lived its entire life and perished long before our sun was born. It survived the apocalyptic death of that parent star, likely a massive supernova that obliterated its home system and violently blasted the comet out into the galaxy. For 3 billion years, it cruised the cosmic deep as an icy time capsule, preserving chemical fingerprints of a forgotten epoch. Spotting it today forces us to wonder how many other ancient relics are currently slipping past our solar system completely undetected. While Comet 3I Atlas is only the third confirmed interstellar object ever found, mathematical models indicate dozens or hundreds of these temporal travelers likely zip through our vicinity at any given moment. Each is a shattered piece of a ruined world, enduring disasters we can barely fathom. They act as galactic archaeological treasures, holding unique data about the early universe that no other objects can provide. Furthermore, this wanderer previews our solar system's ultimate cosmic fate. Billions of years from now, our dying sun will likely fling fragments of our world into the void, creating ancient nomads that will baffle astronomers in distant galaxies long after Earth vanishes. Yet, while this comet provided a glimpse into mind-bending cosmic timescales that dwarf human understanding, Webb's surveys were about to uncover phenomena even stranger than ancient visitors from dead star systems. Building on that mind-bending perspective, Webb's deep-field observations soon revealed something even more baffling than ancient comets. Astronomers are currently scratching their heads over 300 mysterious, glowing anomalies scattered across the dawn of time. Dubbed little red dots, these phenomena show up as minuscule crimson specks in the telescope's earliest cosmic snapshots. They completely defy current classification systems because their characteristics are simply too bizarre. For starters, they shine way too intensely. Based on our grasp of early star and galaxy formation, these objects shouldn't be this bright. The puzzle starts with their hue. Typically, a red tint in space points to freezing temperatures or massive distances. While these dots are indeed incredibly far away, dating back to when the cosmos was under 1 billion years old, they also blaze with intense luminosity. They churn out colossal energy through unidentified mechanisms, resulting in a trait combination unseen today. By applying sophisticated methods like spectral energy distribution analysis and infrared imaging, University of Missouri researchers pinpointed exactly 300 of these perplexing specks in the dataset. While their physical footprint mirrors infant galaxies, their light output shatters predictive models. If classified as galaxies, they are entirely alien compared to modern ones. Their brilliance forces experts to rethink the timeline of early galactic birth. Standard theories dictate that primordial galaxies expanded gradually, gathering mass through gravitational collapse across hundreds of millions of years. However, these crimson specks imply some mechanism assembled gigantic, radiant structures at speeds current physics doesn't permit. The plot thickens when scientists try pinpointing the actual light source because the data is highly contradictory. Certain dots look like single points, hinting that supermassive black holes, rather than widespread starbirth, might be the engine. Conversely, other dots display spread-out features, pointing toward actual galaxies experiencing absurdly fast star creation. The most unsettling theory is that these anomalies belong to an entirely unrecognized stage of cosmic development. During that initial billion-year window, the cosmos operated under radically different rules. The cosmic web was still knitting together, dark matter interactions happened more often, and matter was packed denser. This unique environment possibly birthed structures physically impossible to form today. Adding to the weirdness, several dots exhibit extreme high-energy activity. They blast out ultraviolet radiation, X-rays, and infrared light in chaotic patterns, screaming violent energy generation. Their engines operate in extreme environments, testing the limits of established physics. Furthermore, instead of clustering in anticipated galactic nurseries, they sprinkle randomly across the void. This scattered layout implies they could be a core feature of the infant cosmos, rather than isolated freak accidents. Bang Jiang's son, the graduate student spearheading this study, points out that confirming even a small fraction of these objects demands a total rewrite of galactic formation textbooks. The massive volume of puzzles uncovered proves our grasp of early cosmic history has giant blind spots. Ultimately, these little red dots stand as arguably the biggest cosmological headache the telescope has delivered. Yet, as perplexing as they are, this enigma pales in comparison to the shocking discoveries waiting in the universe's large-scale architecture. Examining the cosmos's grand architecture reveals something truly bizarre. Across massive space stretches, galaxies spin in perfect sync, hinting the universe itself might have been born spinning. In what might be the James Webb Space Telescope's most reality-bending find, researchers notice star systems millions of light-years apart rotating in highly coordinated ways. This cosmic dance breaks our current rules for structure formation, suggesting the entire cosmos has a built-in, preferred spin direction. This revelation came from studying 263 galaxies in Webb's Advanced Deep Extragalactic Survey. Checking the orientation of these distant systems uncovered a scenario that standard cosmology says cannot happen. Star systems too far apart to gravitationally influence each other are somehow twirling in identical directions. Imagine every windmill across a massive continent spinning the exact same way, despite no overall wind pattern guiding them. Separated by gaps so enormous light needs millions of years to cross, they remain locked into the same rhythmic motion. Leo Shamir, the computer scientist heading up this research, pointed out two potential reasons for this weird behavior, and neither option is very comforting. Option number one is that the universe actually started out spinning. If the Big Bang carried its own angular momentum, it could have stamped a specific rotational direction onto all the cosmic structures that formed later. This idea fits perfectly with black hole cosmology, which proposes that our whole observable universe is just the inside of a giant black hole sitting in a bigger parent universe. If true, the synchronized spins Webb spotted might just be the parent black hole's own rotation, echoing across vast distances through physics we have not figured out yet. The second possibility is even worse for standard physics. If the cosmos did not start out spinning, then these matching galaxy rotations mean our current theories on cosmic evolution are missing huge pieces. Some mysterious force or field would have to be acting on a scale way bigger than anything researchers have ever imagined. A spinning universe would operate under totally different physical rules compared to the static one described by traditional models. Space and time could actually have favored directions, leading to lopsided physical laws that would change everything from tiny particle interactions to how the universe eventually ends. This finding also throws a wrench into our understanding of dark energy. If there is a preferred axis of rotation, dark energy might push harder in certain directions, making the cosmos expand faster one way than another. This could actually solve some of the weird expansion rate glitches Webb has been detecting. Perhaps the craziest takeaway is what this means for our spot in the grand scheme of things. If our universe is twirling inside a bigger framework, we could just be inside one small piece of a massive multiverse, where whole universes spin around like tiny galaxies in a higher dimensional realm. Ultimately, these synchronized galactic spins throw a massive wrench into our grasp of how space and cosmic structures work. But the secret spins of the cosmos were only the start of Webb's attack on standard physics. The telescope's very next find would expose black holes being born through methods that simply should not exist. Right on cue, astronomers witnessed a supermassive black hole materializing in real time, completely shattering our understanding of stellar evolution. Deep in space, the James Webb Space Telescope spotted a spectacular galactic crash, birthing something entirely unprecedented. Inside the Infinity Galaxy System, researchers found a colossal black hole that seemingly emerged from pure gravitational collapse, skipping the usual stellar death phase. Crazily enough, it sits in a zone where black holes are theoretically forbidden. This dark behemoth floats in a massive cloud of glowing hydrogen, perfectly positioned between the nuclei of two smashing galaxies. Usually, merging galaxies cause their central supermassive black holes to spiral together, eventually combining or ejecting one into space. However, the Infinity Galaxy ignores this script, stranding its black hole in a gravitational wasteland. Researchers Pieta Vanum and Gabriel Brahma stumbled upon this bizarre setup while digging through Webb's deep field photographs. They were initially drawn to its unique figure-8 appearance, but subsequent checks uncovered a much bigger secret. Radio signals highlighted a giant black hole sitting precisely where scientific models claim it couldn't possibly survive. Think of this direct collapse method like a massive cosmic avalanche. As the two galaxies slammed together, they generated gigantic rivers of gas funneling between their centers. Under perfect circumstances, these gas flows grew incredibly dense, imploding straight into a black hole without ever igniting into stars. It was pure gravitational crushing, entirely bypassing the normal stellar life cycle. This revelation clears up one of Webb's most baffling mysteries. The observatory keeps spotting ancient supermassive black holes way too huge for their young age. The standard recipe involves waiting for giant stars to be born, live, and explode in supernovas, a timeline stretching hundreds of millions of years. Yet, Webb has spotted fully grown supermassive black holes a mere 600 million years post-Big Bang. Because direct collapse black holes begin with colossal raw material, they bulk up to supermassive proportions incredibly fast. Rather than starting small and slowly eating their way up, they are born weighing potentially millions of times more than our sun. This massive head start perfectly explains the giant monsters lurking in the early cosmos. Today, the Infinity Galaxy acts as a live testing ground for this wild creation method. We can literally watch the black hole feast on gas bridging the two galactic centers, packing on weight in real time. This proves black hole birth is vastly more aggressive and swift than experts ever guessed. Still, this direct collapse idea brings up unsettling thoughts about the brutal violence of the early universe. If this was common back then, galaxy birth involved apocalyptic collisions capable of instantly forging the heaviest objects in existence. It also hints that supermassive black holes aren't just accidental side effects of galactic growth, but the main architects organizing matter across vast distances. Ultimately, the Infinity Galaxy confirms the cosmos utilizes hyperviolent, ultra-fast shortcuts to build giant structures. Yet, as mind-blowing as this rapid birth is, it still fell short of explaining the extreme cosmic gluttony Webb was about to witness next. The observatory's following target would unveil a terrifying beast devouring material at speeds that completely defy physics. That terrifying beast turned out to be an ancient black hole swallowing matter 40 times faster than nature permits, growing at an impossible pace. Hidden among countless deep space X-ray emissions, the James Webb Space Telescope spotted this supermassive giant, shattering foundational rules governing how rapidly cosmic titans eat. Cataloged as LID 568, this anomaly ingests material at 40 times its theoretical threshold, a velocity so outrageous it upends our grasp of black hole mechanics. Every black hole possesses an Eddington limit. This is the absolute ceiling for matter accumulation before extreme radiation pressure from superheated gas blasts away incoming fuel. Imagine sipping from a blasting fire hose. Once water flows too fast, the sheer force stops you from drinking. Yet, LID 568 miraculously chugs from 40 fire hoses simultaneously. Uncovering this marvel demanded a team-up between Webb's infrared vision and NASA's Chandra X-ray Observatory. Initially, LID 568 was lost in a sea of thousands of brilliant X-ray beacons, hidden from standard optical lenses while shining fiercely in high-energy light. Fortunately, Webb's specialized infrared tools let researchers pinpoint the subtle counterpart glow, exposing the object's true nature. The most unsettling part of this ravenous binge is its expansion. Pulling in material so frantically means LID 568 likely packed on most of its current weight during one explosive eating spree. Researchers believe it is currently experiencing a massive feeding episode, which involves gobbling up colossal quantities of stuff over a surprisingly short cosmic window. This behemoth was active a mere 1.5 billion years post-Big Bang, back when the cosmos was just a baby. If a black hole were to achieve supermassive proportions that fast while obeying standard dietary restrictions, it would have to begin as an unbelievably gigantic seed. However, the outrageous eating speed of LID 568 offers a brilliant fix to this universal timing puzzle. Judging by the velocity and volume of debris blasting away from the core, a huge chunk of its weight gain probably happened during comparable binges. We aren't talking about slow, steady growth stretched across eons. Instead, these are brutal, rapid-fire consumption bursts capable of multiplying a black hole's size by massive margins in the blink of a cosmic eye. Naturally, the actual science behind such aggressive dining remains a massive mystery. This entity is magically keeping its intake stable, even though the radiation pushback should theoretically scatter its meal. It either invented a clever trick to manage that radiation force, or the nearby material possesses unique traits that stop it from getting swept away. Ultimately, LID 568 showcases the absolute wildest extreme of black hole dining, functioning in an environment that stretches the rules of physics right to the snapping point. This revelation hints that the infant universe was home to eating binges vastly more aggressive and swift than whatever we observe in today's space. Such rapid gorging ghosts might finally clarify how supermassive giants achieved their gargantuan proportions so early in the timeline. Rather than inching upward over billions of years, they likely survived short, ferocious eating binges that ballooned their weight tenfold or greater. Yet, the rule-breaking appetite of LID 568 was merely a single taste of the weirdness Webb kept uncovering across the ancient sky. These deep space scans were proving that the universe's toddler years were infinitely more chaotic and brutal than we ever dared to dream. Adding to that sheer chaos, astronomers are now staring at colossal galaxies sitting completely dead and silent in zones where they absolutely should be birthing stars. Experts are totally baffled as to why these massive systems suddenly halted their growth. Thanks to the James Webb Space Telescope, scientists have uncovered sleeping beauty galaxies sprinkled across the dawn of time. These gigantic star clusters mysteriously powered down their stellar nurseries right when they were supposed to be at peak activity. Even though these cosmic titans hold billions of stars, they display zero evidence of making fresh ones, completely shattering our standard models of youthful galactic evolution. This mind-bending revelation happened while researchers studied systems that took shape between 600 million and 6 billion years post-Big Bang. Back then, the cosmos was packed with dark matter and gas, setting up the perfect recipe for explosive star birth. Practically every galaxy from that epoch ought to be glowing fiercely with newborn suns, greedily devouring available gas to bulk up their stellar ranks. Yet Webb spotted a ton of heavyweight galaxies that seemingly slipped into a deep cosmic nap. These structures boast stellar weights rivaling our Milky Way, but they lack any of the energetic star-making action we expect. Imagine a sprawling metropolis where every construction crew just dropped their tools for absolutely no reason. That is exactly why they earned the Sleeping Beauty moniker, remaining totally inactive during what should have been their most vibrant era. Much like the famous storybook princess trapped in a magical slumber, these galaxies froze right at the pinnacle of their growth. However, unlike the fairy tale, we don't have a clear explanation for this cosmic snooze. Researchers have floated a few ideas to decode this weird behavior, and every single one messes with our core beliefs about how galaxies mature. The first guess points to central supermassive black holes getting so hyperactive that their energy blasts bake the surrounding gas, making it way too hot to collapse into stars. While this active galactic nucleus feedback can kill star birth across a whole galaxy, the timeline is completely off. These sleeping beauties stopped making stars before their central supermassive black holes fired up enough to cause that kind of massive heating. Another idea suggests these galaxies ate through their gas reserves so fast during an early frenzy that they ran out of fuel. This requires star formation speeds way beyond current math, hinting ancient galaxies were vastly more efficient than modern ones. Then there is the most unsettling theory. These sleeping beauties might have run into a totally alien process that simply doesn't happen today. The infant cosmos functioned under radically different physical rules, boasting denser matter and unique dark matter layouts. Maybe those ancient conditions sparked a star-killing mechanism we have never observed. Ultimately, finding these snoozing giants so early drastically shifts how we view cosmic history. If heavyweight galaxies could hit the brakes on their growth that early on, it proves galactic evolution is wildly more complicated than experts assumed. These dormant beauties add more proof that the infant universe was a much weirder, far more extreme environment than our models predicted. But cosmic weirdness isn't just confined to the ancient past. It is actively drifting through our galactic neighborhood today. Consider a starless world wandering the void, boasting the most astonishing atmosphere ever recorded, featuring distinct cloud decks formed from magnesium and iron minerals. Known as SIMP-136, this object is completely alien compared to anything orbiting our sun. Rather than circling a host star, this solitary traveler roams the Milky Way freely, glowing solely from the faint warmth of its own internal energy. When the James Webb Space Telescope conducted a deep dive into its atmospheric makeup, the findings were totally groundbreaking. Researchers discovered a stratified sky where droplets of liquid iron plummet through upper decks of magnesium-based clouds, resembling a multi-tiered celestial cake with various metallic vapors stacked at different heights. Close to the ground, a thick blanket of iron clouds generates weather completely alien to earthly standards. Instead of gentle water mist, you get heavy, dense clouds of vaporized metal that eventually cool and drop as molten iron precipitation during fierce storms. Further up, a secondary deck made of forsterite, a magnesium-heavy silicate frequently spotted in space rocks, drives a totally separate weather cycle. These specific silicate formations only appear when the local pressure and heat hit the exact sweet spot for magnesium to vaporize and then condense. The way these two distinct decks interact completely shatters our current limits of planetary science. Webb's infrared data showed that both the magnesium and iron decks are highly patchy and in constant flux, pointing to highly active, whether fueled by the world's spin and its deep internal warmth. Interestingly, the iron vapors seem to circulate differently than the magnesium ones, building a highly intricate, three-dimensional sky that shifts wildly from one region to the next. Yet the biggest puzzle sits high above both of these metallic decks, where the telescope spotted what scientists refer to as hotspots. These intensely warm zones seem to be fueled by radio auroras. Think of Earth's northern lights, but cranked up to energy outputs that would instantly obliterate any known living organism. Such powerful radio auroras indicate that SIMP-136 possesses a monstrously strong magnetic field, dwarfing anything we see in our own stellar neighborhood. This massive magnetic shield clashes with charged interstellar particles, generating electrical currents that bake the upper sky to temperatures far hotter than the metallic storms raging below. Alison McCarthy, the graduate student who spearheaded this research, noted that the world exhibits atmospheric variability that theorists had previously only guessed at, but never actually seen in the wild. The intricate dance between the radio auroras, magnesium decks, and iron storms operates on entirely new physical rules. Finding such rich chemical complexity on a starless world forces us to rethink how planets form and evolve. SIMP-136 somehow built and kept this wild atmosphere while floating in the freezing, dark void, completely cut off from any star's warmth. This implies that starless worlds might host far more intricate weather than we ever gave them credit for. If a single wandering sphere can produce magnesium clouds and iron rain, millions of similar rogue worlds could be hiding across the Milky Way, each showcasing bizarre weather we never thought possible. Ultimately, this metallic raindrop of a world establishes a brand new class of planetary skies, forever changing how we view extraterrestrial weather. While that metallic raindrop redefines planetary weather, a completely different extreme cosmic climate is tearing entire galaxies apart. Deep in space, a bizarre system shaped just like a cosmic owl is swimming through the void, showing off tentacle-like features that point to unprecedented violent encounters. When the James Webb Space Telescope photographed this object, researchers affectionately dubbed it the cosmic owl due to its unique look. A luminous core gives off the impression of two shining eyes, and the encircling dust and gas mimic the feathery facial disc of an actual owl. However, a closer look proved this celestial bird is much stranger and more unsettling than its cute moniker implies. In reality, this object falls into a category known as jellyfish galaxies, which look like they are paddling through the cosmos with lengthy trails of stars and gas streaming behind them. Rather than just pretty visual quirks, these trailing limbs prove brutal stripping mechanisms are ripping the system to shreds as it travels. Specifically, this system is experiencing ram pressure stripping. As it speeds through the scorching gas that permeates galaxy clusters, it faces a massive cosmic headwind that quite literally blows chunks of its physical structure away. Picture cruising down the freeway in a convertible with unsecured items in the back, watching them fly out into the wind. That is exactly how this owl-shaped system is shedding pieces of itself on its journey. Webb's infrared capabilities now reveal the full scale of this brutal event. The trailing limbs extend across hundreds of thousands of light years, harboring billions of stars violently evicted from their birthplaces. Functioning as stellar refugees, these suns are now stranded inside the tentacles, cut off from their host galaxy and gradually scattering into the empty darkness. Yet the most unsettling takeaway isn't just the material being lost, but what this extreme stripping tells us about the surrounding cosmic neighborhood. Generating such massive tentacles requires immense ram pressure, meaning this galaxy plows through a remarkably hot, dense medium, completely unlike the mostly empty vacuum between galaxies. Consequently, the cosmic web, the massive framework linking universal matter, turns out to be far more chaotic and aggressive than experts once thought. Rather than gliding peacefully through a quiet vacuum, galaxies are actually battling through harsh conditions capable of ripping them to pieces. Interestingly, this jellyfish effect also sparks fresh star birth right inside those trailing limbs. As the headwind rips and compresses gas, it ignites sudden bursts of star creation far outside the main galactic disk. So the cosmic owl is essentially being dismantled, while simultaneously birthing brand new stellar families in its wake. Webb actually spotted active stellar nurseries sprinkled all along these tentacles, shining with a brilliant blue hue from hot, newly formed giant stars. Floating in gravitational isolation, these glowing nurseries sit billions of light years from the parent system that supplied their initial ingredients. Finding so many jellyfish formations across Webb's deep field pictures implies stripping events and galactic cannibalism happen way more often than we ever guessed. Our universe could be absolutely packed with cosmic refugees, including wandering gas clouds and rogue stars ripped from their homes to drift endlessly through the dark. Ultimately, this owl-shaped wonder is merely a single showcase of the sheer brutality driving large-scale galactic evolution. However, as massive as this galactic teardown is, it barely compares to the intense stellar brutality Webb has uncovered happening inside individual star systems. Peering deep into these very systems, Webb has spotted something truly baffling. Infant stars are cooking up heavy elements that simply have no business being there yet. The telescope caught young stellar nurseries churning out massive amounts of nitrogen, carbon, and oxygen. According to standard stellar evolution models, this complex cosmic chemistry takes billions of years to build through countless cycles of stars being born and dying. To understand this puzzle, we look at metallicity, the astronomy term for any element heavier than helium and hydrogen. Right after the Big Bang, the cosmos was basically just a soup of those two ultralight elements. Everything else, from gold and iron to oxygen and carbon, had to be cooked inside the blazing cores of giant stars and scattered across the void when they exploded as supernovas. Naturally, this cosmic baking takes time. The very first stars, known as Population 3, formed almost exclusively from that primordial hydrogen and helium mix. Once they died, they seeded their neighborhoods with freshly forged heavy materials, allowing the next generation to ignite with a slightly richer chemical makeup. Over billions of years, this endless recycling loop slowly cranks up the metallicity in star-forming regions. Yet, Webb is finding stellar nurseries that seem to have completely cheated this gradual timeline. We see baby galaxies, born when the cosmos was under 1 billion years old, flaunting chemical richness that demands many generations of stellar life. They pump out carbon, oxygen, and nitrogen way too fast for their young age. The wildest case is galaxy JWST 131, spotted a mere 330 million years after the dawn of time. Spectroscopic analysis revealed glowing hydrogen signatures alongside clear proof of heavy element creation, proving this toddler galaxy had already lived through major evolutionary changes. Facing this chemical impossibility, astronomers must rethink early star formation. Either the original population 3 stars were way bigger and burned out much faster than predicted, spitting out heavy elements at lightning speed, or a totally mysterious mechanism loaded the infant universe with complex atoms. If the first idea is right, those early stars were absolute cosmic monsters, potentially weighing hundreds of times more than our sun. These colossal giants would have guzzled their nuclear fuel in just a few million years, detonating as hypernovas that blasted heavy materials across enormous swaths of space. While stars this gigantic don't exist today, the extreme environment of the early universe might have allowed their formation. The alternative explanation is arguably more mind-bending. If a hidden process manufactured heavy elements back then, our grasp on cosmic chemical evolution has massive blind spots. It implies something completely different from standard stellar nucleosynthesis was hard at work during the universe's childhood, cooking up complex chemistry through undiscovered pathways. This lightning-fast chemical enrichment also shakes up our ideas about planet formation and early life. If the universe was stocked with heavy elements much earlier than assumed, rocky worlds and the essential ingredients for biology could have appeared way ahead of schedule. Ultimately, Webb's findings reveal that the infant cosmos was incredibly chemically complex, making our current theoretical models look like crude, oversimplified sketches of reality. It isn't just the distant, ancient universe that defies expectations. Even our own cosmic backyard hides mind-bending secrets. Take a mysterious world orbiting our closest stellar neighbor that keeps popping in and out of Webb's view, leaving scientists puzzled about its existence. Hailed as the telescope's most crucial discovery so far, this massive exoplanet was spotted circling Alpha Centauri A, the nearest sun-like star. Yet, when researchers looked again, it had completely vanished. This ghostly disappearance sparked one of the most confusing puzzles in exoplanet research. Given the temporary label of Alpha Centauri AB, this object first showed up as a distinct heat profile matching a Neptune-sized globe inside the host star's habitable zone. Finding such a world would have been a monumental achievement, marking the nearest potentially life-supporting environment to Earth. However, excitement faded when subsequent scans failed to verify the initial sighting. Later imaging runs revealed absolutely zero evidence of the once obvious heat signature. It was as if the world had either drifted into a blind spot or literally blinked out of existence. Scientists have brainstormed a few theories to explain this phantom world, and every idea pushes the boundaries of solar system knowledge. One theory proposes a highly stretched, oval-shaped path taking the globe incredibly far from its sun for most of the year. We would only catch its heat signature during a short window when it swings close enough to warm up. The problem is basic physics. A world on such a wild trajectory around Alpha Centauri A wouldn't be gravitationally stable. The complex tug-of-war from neighboring star Alpha Centauri B would likely fling the planet out of the system. A second hypothesis is arguably even stranger. The globe could actually be there, but hidden behind shifting dust or space junk that occasionally blocks Webb's infrared vision. If true, this implies the Alpha Centauri environment is incredibly chaotic, filled with constant crashes and disturbances throwing up temporary smoke screens. Then there is a third option that completely rewrites the rules of planetary birth. That heat profile could belong to an embryonic planet still forming, gathering matter from a leftover disk in unpredictable bursts. These growth spurts would cause it to flash in and out of the telescope's view. This implies brand new planets are still being built in the Alpha Centauri neighborhood, which is shocking considering these stars are billions of years old. But the most unnerving theory is that Webb never saw a planet in the first place. That mysterious heat bloom might actually be a totally new class of space anomaly. It could be a thick cluster of heated rubble, or maybe a botched attempt at star birth in the distant outskirts of the system. Ultimately, this ghostly puzzle proves just how much we still have to learn about solar systems, even the ones right next door. If an entire world can play hide-and-seek in our closest stellar backyard, you have to wonder what other bizarre planetary tricks are happening right under our noses. This incredible vanishing act is a perfect reminder that the universe is packed with surprises ready to shatter our fundamental beliefs. And speaking of shattering beliefs, Webb has uncovered a mystery that literally looks like it has a mind of its own. Deep within the cosmic web, scientists found ancient magnetic fields older than any known structure, rivaling the complexity of the human brain. Webb revealed these forces stretch across the universe's most massive formations, weaving connectivity patterns eerily similar to our own neural pathways. These primordial relics date back to the universe's first billion years, when cosmic architecture was taking shape through mechanisms we barely grasp. This revelation came from Webb observing the cosmic web, the gigantic framework of voids and filaments organizing matter between galaxy clusters. Here, thin rivers of dark matter and gas build bridges stretching hundreds of millions of light years. Webb discovered these threads are laced with astonishingly intricate magnetic fields. Such organization simply shouldn't exist in the infant universe. Instead of basic, uniform fields, the telescope found elaborate webs with hierarchical layouts, connections, and nodes perfectly mimicking biological brain topology. The resemblance is so profound that scientists now use the exact mathematical models designed for human brain connectivity to study this cosmic magnetism. This flips standard cosmic evolution models upside down. Traditionally, experts assumed magnetic fields grew slowly over billions of years, amplified by supernovae and stellar winds as galaxies formed. However, these primordial fields predate that timeline entirely, shaping early galaxies in ways current theories ignore. Magnetic pressure and reconnection events might have dictated how gas collapsed into the first stars, directly influencing chemical evolution, formation rates, and stellar masses. Perhaps most unsettling is what this means for cosmic structure formation. These brain-like layouts prove the universe achieved massive organizational complexity far earlier than believed. Instead of just simple gravitational collapse, the early cosmos may have functioned like a giant information processing system. Furthermore, these webs are highly dynamic, with links constantly breaking and forming. Webb even spotted magnetic storms engulfing whole galaxy clusters, steering star birth across enormous regions. This also carries huge implications for dark matter and dark energy. Since magnetic fields interact with charged particles, they alter how matter clumps on large scales. If early magnetism was more powerful and complex than assumed, it could explain the structural discrepancies Webb keeps finding. Ultimately, these neural-like webs challenge everything we know about emerging complexity. If the young cosmic web hosted such advanced structures, the universe has a built-in drive toward complexity we never recognized. It hints the cosmos might share traits with living systems, boasting information processing capabilities born from physical laws we have yet to decipher. Speaking of living systems, the very heart of our galaxy appears to be beating. At the Milky Way's center, a supermassive black hole pulses with strange, irregular rhythms, hinting at bizarre physics at the boundary of spacetime. For decades, Sagittarius A, our galaxy's central black hole weighing 4 million solar masses, has quietly astonished scientists. However, continuous observations by the James Webb Space Telescope have uncovered something entirely new. This colossal entity displays wild brightness shifts, acting like a heartbeat lacking any recognizable rhythm. By utilizing Webb's near-infrared camera, scientists tracked Sagittarius A for a total of 48 hours, divided into various sessions over a single year. They found a black hole that never sits still. Its accretion disk generates a non-stop, messy stream of shifting light, interrupted by intense, unexpected flares. Researchers witnessed a bubbling, ever-changing glow around the event horizon. Suddenly, huge radiation explosions would burst from the disk without warning, only to settle down shortly after. These flashes seem totally arbitrary, completely resisting any efforts to map out a predictable cycle or hidden sequence. Farhad Youssef Zard, the Northwestern University professor heading this study, noted that such conduct is entirely unique among supermassive black holes. Because the team could not detect any recurring themes, they suspect the forces behind these light shifts rely on physical rules that our existing theories simply do not comprehend. Scientists believe two distinct processes are driving this galactic pulse. The brief flickers probably stem from chaotic turbulence inside the accretion disk, where clashing magnetic fields squeeze plasma to spark quick radiation bursts. You can picture this as cosmic lightning flashing through intensely hot gas as it swirls down toward the event horizon. The bigger flares, however, point to a much more extreme scenario. These enormous spikes in luminosity could happen when massive clumps of material pass through the photon sphere. This is the specific zone where light actually orbits the black hole, right before it either breaks free or plunges past the event horizon for good. Such unpredictable activity proves that Sagittarius A is far more lively than experts once thought. Rather than the calm, slow-eating giant portrayed in standard textbooks, our galaxy's core black hole seems locked in a perpetual state of mild aggression, swallowing material in highly erratic bursts. The most mind-bending part of this behavior is what it means for the physics right next to the event horizon. These light variations start in zones where gravity heavily warps space and time. This sets up an environment where energy and matter follow rules that stretch general relativity to its absolute breaking point. The messy, random shifts in brightness also hint that quantum mechanics might be influencing how the black hole feeds. Close to the event horizon, the line separating quantum and classical physics gets incredibly fuzzy, possibly giving rise to events found nowhere else in the cosmos. Furthermore, this pulsing rhythm brings up major questions regarding the fate of information tumbling into a black hole. Should the accretion disk truly be acting at random, it could mean black holes obliterate information, which would break the core rules of quantum mechanics. Ultimately, the erratic beating of Sagittarius A gives us our most intimate view of physics under the most intense conditions imaginable, a place where gravity is so overwhelming that the very fabric of space and time starts to tear apart. But while a supermassive black hole warps spacetime locally, an even grander drama unfolds across the universe's vast expanse. Unseen forces are actively remodeling the cosmos through brutal mechanisms, leaving a trail of mangled galaxies strewn across millions of light years. The James Webb Space Telescope recently exposed how dark matter, the enigmatic material comprising 85% of all cosmic mass, engages in fierce battles. These clashes are powerful enough to rip entire galaxies to shreds and completely reorganize the universe's grand architecture. Because these dark matter disasters emit no light, we only witness them through the absolute devastation they inflict on regular, visible matter. Researchers found this proof by pointing Webb at galaxy clusters, massive cosmic neighborhoods where hundreds of galaxies are bound by immense dark matter halos. When these gigantic clusters smash together, they trigger monumental energy releases rivaling billions of supernovas. However, Webb's high-resolution pictures showed the destruction doesn't stop at the crash site. Even galaxies situated millions of light-years from the main impact zone bear the scars of severe gravitational mutilation. This widespread damage points to dark matter operating on an unimaginably huge scale. The telescope spotted massive rivers of gas and stars linking distant galaxies, forming enormous bridges across the void. These stellar ribbons are essentially the mutilated corpses of galaxies, torn apart by dark matter gravity during cluster pileups. What makes this universal brutality so eerie is its stealth. When regular matter crashes, it puts on a brilliant light show of electromagnetic radiation. Dark matter generates zero heat, zero light, and absolutely no electromagnetic footprint. We only know it happened because of the gravitational toll it takes on the stuff we can actually see. Thanks to its incredible infrared vision, Webb has finally exposed the true scope of this shadowy warfare. Previous instruments lacked the sensitivity to see the delicate tidal tails and faint star streams stretching millions of light years around these clusters. Now, we see gigantic spiderwebs of ruined material, with every strand representing a galaxy severely damaged or totally annihilated by dark matter. The sheer magnitude of this ruin proves dark matter is far more than a quiet, invisible skeleton holding the cosmos together. It actively remodels the universe, capable of kicking galaxies out of clusters, stealing their gas, and flinging stars into the void. Digital simulations suggest these brutal encounters are essential for cosmic evolution. As dark matter particles collide and interact gravitationally, they send massive shockwaves rippling through the cosmic web, dictating how galaxies form over enormous distances. This raises a fascinating question about what dark matter actually is. If it engages in such high-energy brawls, it must possess traits beyond basic gravitational pull. Certain theories suggest dark matter might experience phase changes or communicate through entirely unknown forces. Realizing dark matter is this violent completely rewrites our rulebook for galactic evolution. If galaxies are perpetually smashed and rebuilt by unseen hands, the cosmos is infinitely more chaotic than standard models assumed. These silent disasters are a core pillar of cosmic history, operating in the shadows and molding our universe through a brutality we can only piece together from the wreckage. But while dark matter violence tears structures apart, other cosmic forces are busy twisting reality itself into knots. Far out in the deep cosmos, a distant galaxy is warping spacetime so intensely that it causes background light to appear in several places at once, testing the limits of general relativity. Thanks to the James Webb Space Telescope, we've found a system so incredibly heavy that its gravity projects multiple copies of a background galaxy across the sky, each capturing that distant star system at a completely different life stage. We call this strong gravitational lensing. It happens when an object packs so much mass that it curves spacetime like a giant magnifying glass, forcing light from further objects along bent routes to create warped or duplicated pictures. Yet the lensing produced by this specific galaxy is way more intense than anything previously observed. Webb spotted at least 4 distinct copies of the exact same background galaxy, with every single one magnified differently to showcase the system during various historical eras. The gravitational pull is so immense that light requires a different amount of time to journey down each bent trajectory. Because of this time delay, researchers are basically viewing parallel timelines of the exact same galaxies passed all at once. One picture displays the system as it looked 800 million years ago, while a second copy exposes its layout from a full billion years in the past. The lensing galaxy has essentially transformed into a cosmic time machine, broadcasting stellar evolution across multiple eras. The truly unsettling part of this find is the hidden mass distribution required to bend spacetime this drastically. This system must be packed with dark matter densities that completely blow past current model predictions. This invisible material seems bunched into formations that defy our understanding of how these ghostly particles interact and organize. Furthermore, the lensing highlights dark matter substructures that standard cosmology says shouldn't exist. Rather than finding smooth dark matter halos, Webb picked up signs of dense clumps and empty voids, hinting at complicated internal movements driven by unknown mechanisms. Measuring the time delays between these duplicated images provides rock-solid proof of spacetime curving exactly as general relativity forecasts. However, the sheer extremity of this lensing pushes the physics into a zone where quantum gravity might actually start influencing classical spacetime geometry. Perhaps the creepiest takeaway is what this implies about the prevalence of such extreme gravitational environments. If a single galaxy can warp reality this aggressively, the universe might hide countless other regions where space and time are twisted beyond our capacity to model. These duplicated views also prove the lensed galaxy itself is changing at a breakneck pace, with star formation rates shifting wildly between the different time periods captured in each picture. This gives us an unmatched look at how galaxies transform during their most hyperactive stages. Ultimately, this time-warped system acts as a perfect natural laboratory for testing general relativity under extreme conditions, proving how thoroughly massive objects can physically remold the shape of space and time. These gravitational tricks happen on a scale where traditional physics starts to fall apart, potentially exposing brand new cosmic secrets hiding right on the boundary between general relativity and quantum mechanics. Transitioning from those mind-bending quantum boundaries, we zoom out to witness a different cosmic violence, where gravity drives stars to literally eat each other. Across the universe, suns aggressively consume their partners, sparking entirely new explosive phenomena. Thanks to the James Webb Space Telescope, we now have direct visual proof of widespread stellar cannibalism. Binary pairings frequently meet disastrous ends, with one sun swallowing its sibling, creating blasts so energetic they temporarily outglow whole galaxies. This gruesome process kicks off when stars orbit so tightly that their outer layers mingle. The heavier sibling siphons material from the smaller one, pulling superheated gas into glowing accretion disks. While this transfer might begin leisurely, it can rapidly accelerate into a catastrophic gulping of the victim. Using its incredible infrared capabilities, Webb observes these chaotic feasts clearly. Piercing through thick dust clouds that usually hide such brutality, the observatory maps the intricate gravitational ballet of matter flowing from prey to predator. The most intense scenarios feature white dwarfs. These dense, Earth-sized corpses of dead stars pack our sun's entire mass. As these vampiric objects gorge on stolen gas, they ignite colossal thermonuclear detonations called type supernovas, briefly eclipsing billions of ordinary suns. However, Webb has spotted even fiercer acts involving black holes and neutron stars. When these compact behemoths feast on partners, they spark kilonova blasts. These eruptions shoot gamma-ray bursts visible across billions of light years, while forging precious heavy metals like platinum and gold. Remarkably, the telescope has recorded this entire cannibalistic life cycle. We can watch the first moments of material theft, track the rapid feeding acceleration, and observe the ultimate detonation scattering newly forged elements across the void. Unsettlingly, these stellar meals occur frequently. Webb's data implies this brutal consumption is a core engine for chemical evolution, producing the crucial heavy ingredients needed to build planets and living organisms. The sheer force of these detonations also impacts nearby stellar nurseries. Shockwaves can either kickstart or shut down star birth over massive areas, shaping galactic evolution far beyond the original binary pair. Furthermore, the observatory has caught interrupted meals. In these failed cannibalism scenarios, the binary duo starts feeding but gets disrupted before the finale, leaving behind exotic stellar leftovers with traits totally alien to our local neighborhood. Because this behavior is so widespread, scientists must rethink how binary systems influence cosmic chemistry. Rather than living quiet, solitary lives, countless stars are locked in vicious, predatory relationships ending in spectacular blasts. Ultimately, these violent feeding frenzies serve as a primary mechanism for manufacturing the complex chemical building blocks that make life itself possible. While those violent stellar meals create life's ingredients, they also expose a darker cosmic secret. Growing proof shows the universe's fabric fractures on a massive scale, exposing deep flaws that challenge our most basic understanding of physics. In fact, Webb's most disturbing discovery isn't a single object, but accumulating evidence that spacetime becomes unstable under extreme conditions. Through multiple surveys, the telescope detected gravitational anomalies, unexplained energy signatures, and structural irregularities suggesting general relativity's smooth spacetime is incredibly fragile. For instance, gravitational lensing effects around massive objects don't follow precise theoretical predictions. These persistent deviations appear near black holes, galaxy cluster cores, and other massive structures, indicating spacetime breaks down under extreme gravitational stress. Quantum mechanics predicts that at the smallest scales, spacetime should be foamy and chaotic, with virtual particles and energy fluctuations creating a turbulent quantum foam. Webb's observations suggest this quantum foam might bubble up to macroscopic scales under certain extreme conditions. The telescope detected unexplained energy emissions from regions where quantum effects shouldn't be observable, including mysterious radiation from black hole event horizons and anomalous heating in galaxy cluster cores. These phenomena might represent quantum foam breaching into classical spacetime during particularly violent cosmic events. Perhaps most unsettling are Webb's observations of cosmic strings, hypothetical one-dimensional defects in spacetime that could have formed during the universe's earliest moments. If these structures exist, they represent fundamental cracks in reality itself, places where spacetime is literally torn or folded in ways violating our understanding of cosmic geometry. The telescope identified several candidates for cosmic string signatures, including gravitational lensing patterns that can't be explained by any known distribution of matter or energy. These observations suggest the universe might contain permanent scars from its violent birth, defects that persist as vulnerabilities in the spacetime structure. Webb also found evidence of vacuum decay events, regions where the quantum vacuum transitioned to lower energy states, releasing enormous amounts of energy. These events could represent fundamental phase transitions in the structure of reality itself. The accumulating evidence suggests the universe operates closer to the edge of physical stability than previously believed. Under extreme conditions involving massive gravitational fields, high energy densities, or exotic matter states, the fundamental structure of spacetime might become unstable. These quantum foam breaches have profound implications for our understanding of cosmic evolution and the ultimate fate of the universe. If spacetime can become unstable under naturally existing cosmic conditions, it raises questions about whether reality itself might be more temporary and fragile than we assume. The discovery of quantum effects operating on cosmic scales also suggests the boundary between quantum mechanics and general relativity is more porous than predicted, with huge implications for black holes, cosmology, and the fundamental nature of reality. Building on that blurry boundary between quantum mechanics and gravity, a truly mind-bending concept emerges. Combining the synchronized spinning of galaxies with the bizarre quirks of cosmic expansion leads to a startling idea. Our reality might be nested inside a colossal black hole. The most astonishing implication of the James Webb Space Telescope's findings is that our entire observable cosmos is simply the inner cavity of a gargantuan black hole sitting within a grander reality. This black hole cosmology framework untangles several of Webb's baffling mysteries, addressing both the synchronized galactic dances and the conflicting expansion rates that broke standard models. The proof starts with rotational patterns Webb spotted in deep field scans. Galaxies millions of light years apart are twirling in perfectly aligned directions. This shouldn't happen unless the cosmos possesses a distinct axis of rotation. Under this model, that alignment occurs because our universe inherited the spin from the mother black hole that birthed us. Essentially, the Big Bang was just our cosmos passing through the event horizon of a higher dimensional black hole. To us inside, this transition looks exactly like cosmic expansion. To an outside observer, however, we are merely plunging toward a singularity, a descent stretching into infinity due to gravitational time dilation. This concept also solves the dark energy mystery. As we sink deeper into the parent black hole, spacetime bends more sharply. This intense warping tricks us into perceiving accelerating expansion when we are actually drifting into zones of extreme spatial distortion. Furthermore, Webb's detection of ancient black holes existing before the first stars aligns perfectly with this picture. These early behemoths might be smaller black holes from the parent realm that slipped in with us, appearing in our timeline as primordial relics. Those synchronized galactic spins are no longer a weird coincidence. Everything is just moving to the same rotational beat stamped onto spacetime at our birth. Even clashing expansion measurements make sense here. Various observational methods might simply capture different angles of our journey through the parent black hole's curved spacetime, creating apparent contradictions from these multiple perspectives. If true, everything we see, from the cosmic microwave background to the farthest galaxies, is trapped behind the event horizon of an unfathomably huge black hole. We would be permanently locked inside this cosmic vault, completely cut off from the broader reality outside. Yet the black holes dotting our own sky could harbor their own complete universes. This creates an endless, nested chain of realities, where every singularity acts as a doorway to a brand new realm with unique physics and potentially life. Ultimately, this shifts our entire perspective, revealing our universe might just be a single bubble in an infinite multiverse of black hole realities. Building on the idea that we might reside inside a black hole bubble, the findings from the James Webb Space Telescope do much more than just tweak our cosmic models. They completely redefine humanity's place within a reality that is vastly more bizarre and hazardous than we ever pictured. All our previous beliefs regarding space expansion, black hole growth, and galaxy formation have been blown to pieces. Rather than confirming textbook theories, Webb has shown us a cosmos packed with inexplicable phenomena, aggressive mechanisms, and baffling physical laws. The environment we are looking at now is far from the neat, predictable space we once studied. Instead, we see a chaotic domain where spacetime itself could be fragile, uncloaked black holes roam freely, and galaxies assemble at speeds defying known physics. We reside not in a peaceful, life-nurturing garden, but in a brutal arena where existence can fracture under intense pressure. Maybe the most chilling takeaway involves our profound cosmic loneliness. If our universe truly exists within a larger black hole, we are permanently separated from whatever grander reality lies outside. Any message we broadcast or mission we launch will forever be confined inside this ultimate cosmic jail. Furthermore, the sheer destruction Webb has uncovered directly impacts our long-term survival. With star-eating frenzies capable of wiping out entire sectors, mysterious radio-emitting rogue worlds, and roaming black holes, our galactic vicinity is likely much more hostile than we assumed. The blistering speed of these findings also highlights our profound ignorance. Even with centuries of astronomical study, Webb's initial years have forced a total rewrite of cosmic history, making us wonder what other massive blind spots remain. By spotting primordial black holes and impossibly early galaxies, the telescope proves the cosmos became highly complex much sooner than anyone thought. Consequently, universal evolution could be taking roots we never dreamed of, potentially including the rise of advanced civilizations in completely unexpected environments and timeframes. Yet there is a silver lining. The surprising nature of the cosmos hints at an evolutionary process far richer than our models allow. A reality wild enough to spawn naked black holes and impossible galaxies could easily foster entirely new types of life operating on physical principles we have yet to fathom. Essentially, Webb shows us we are mere toddlers grasping at rules we are only just starting to see. Each bizarre anomaly is a chance to broaden our minds in a reality that loves to shatter expectations. Above all, these revelations teach us the cosmos has no obligation to make sense to us. Existence follows its own alien logic, detached from human intuition. To thrive, our species must align our knowledge with the universe's true nature, rather than clinging to how we want it to be. The reality uncovered by James Webb is often baffling, aggressive, and profoundly weird. However, it is our only home. Deciphering this wild cosmos, no matter how unsettling, remains our greatest strategy for navigating the incredible future ahead.